There are footprints in the New Mexico desert that should not exist. They are preserved in the beds of ancient lakes at White Sands, frozen in time, like photographs of a world we were never meant to know. Small footprints, some belonging to children, others to teenagers and adults. You can see the marks of the toes, the way the mud squished between them. You can follow where the people walked, where they stopped, where a mother set her infant down to rest. These are not just any footprints. They are between 21,000 and 23,000 years old. And according to everything we thought we knew about human history in the Americas, they are impossible. For decades, scientists told us a clear story. The first humans arrived in North America about 13,000 years ago, crossing a land bridge from Siberia during the last ice age. They were Homo sapiens, modern humans, exactly like us, following herds of mammoths and bison into an empty continent. It was a neat, orderly timeline that everyone agreed upon. Then, these footprints appeared, and suddenly nothing was clear anymore. Because if people were walking in New Mexico 23,000 years ago, it means they arrived at least 10,000 years earlier than we ever thought possible. They were there while massive ice sheets still smothered most of North America, when there was supposedly no way through, when the land bridge wasn't even passable yet. And this is where things become truly strange. What if these footprints weren't left by people exactly like us? Stay with me here. This is no wild conspiracy theory. It is a question that serious scientists are asking today, based on mounting evidence from genetics labs, ancient burial sites, and mysterious skulls that don't quite match the appearance of modern humans. What if multiple species of humans reach the Americas? What if the Denisovans, that ghost species we only discovered a few years ago, arrived here first? And what if Neanderthals had somehow crossed the Atlantic? The traditional story of the first Americans is collapsing, and beneath it, we are uncovering something vastly more complex, profoundly stranger, and infinitely more fascinating. If you are listening to this to fall asleep, that's perfect. That is exactly why I make these videos. So feel free to subscribe and let me know where you are and what time it is. I love reading the comments and seeing Tokyo at lunchtime, Toronto at midnight. All of us experiencing this mystery together across the time zones. Picture this. You are standing in White Sands National Park right this very moment, looking down at those ancient footprints as the sun sets over the white gypsum dunes. The shadows make the tracks easier to see. Small indentations in the stone that used to be mud. The people who left these marks were walking along the shore of a lake that dried up thousands of years ago. They were hunting giant ground sloths, massive creatures that would tower over a modern bear. We know this because there are ground sloth tracks right next to the human ones. In one spot, you can see where a sloth reared up on its hind legs, likely startled by the approaching humans. It was a world of megafauna. Mammoths with curved tusks longer than a car, dire wolves, saber-toothed cats, American lions, larger than any big cat alive today. And somehow, a group of humans lived here among these creatures, leaving footprints that would outlast empires. But who were they? That question shatters everything we thought we understood about American prehistory. Because the deeper we dig, the stranger it gets. There are archaeological sites in Chile that might be 18,000 years old. Caves in Mexico containing evidence of human occupation before the ice-free corridor ever opened. Skulls in Brazil and California that look different, truly different, from modern Native Americans. And then there is the genetic evidence, DNA, from ancient remains showing traces of unknown human populations. Ghost lineages that don't match any living group. Hints of interbreeding between modern humans and other species, right here in the Americas. We aren't just rewriting the date of when humans arrived. We are questioning who they were, whether they came all at once, or whether they walked, sailed, or somehow crossed oceans we once thought impassable. Could it be that the first Americans were in some fundamental way a completely different species? This is a journey into deep time, through ice ages that turned half the planet into a frozen wasteland, across vanished land bridges and submerged coastlines, through archaeological sites that keep pushing the timeline further and further back, through genetic mysteries, ancient bones, and yes, those impossible footprints in the desert. The story we are about to tell isn't finished. Every year brings new discoveries that shift the picture, but that is what makes it so incredible. We are watching the rewriting of human history in real time. So let's start at the beginning, or at least what we thought was the beginning. For most of the 20th century, the story of America's first inhabitants seemed settled. It was elegant, it was simple, and it made perfect sense. About 13,000 years ago, during the last ice age, bands of Siberian hunters followed herds of mammoth and bison across a vast land bridge connecting Asia to Alaska. They spread southward through an ice-free corridor, rapidly colonized 2 empty continents, and became the ancestors of all Native Americans. Case closed. This theory, known as Clovis First, dominated textbooks, shaped museum exhibits, and defined entire careers. It wasn't just a scientific consensus. It became something akin to archaeological dogma. Anyone who questioned it risked professional ridicule. But here is the problem with scientific orthodoxy. Sometimes it's right, and sometimes it's just comfortable. Let's start with what we know for sure. During the last ice age, roughly 30,000 to 11,000 years ago, immense ice sheets covered much of North America and Eurasia. We aren't talking about a few extra feet of snow. These were walls of ice, reaching 2 miles thick in places, grinding down the landscape, locking up so much water that global sea levels plummeted by 400 feet. When you pull 400 feet of water out of the ocean, geography changes dramatically. Shallow seas become solid ground. Islands connect to the mainland. And most importantly for our story, a narrow strait between Siberia and Alaska transforms into something entirely different. Beringia, the Bering Land Bridge. Picture this in your mind's eye. Not a narrow path or a temporary bridge of ice. A subcontinent 1,000 miles wide from north to south, stretching from eastern Siberia to western Alaska. Grasslands and tundra as far as the eye can see, intersected by river valleys and sparse groves of trees in the more sheltered areas. It wasn't a frozen wasteland. Archaeological and geological evidence shows that Beringia was a remarkably productive environment. Cold, yes, but dry and relatively stable. The kind of place where large animals could thrive. And they did. Mammoths moved across these grasslands in gigantic herds. Not just any mammoths, but woolly mammoths, perfectly adapted to Ice Age conditions, with coats up to 3 feet thick and curved tusks capable of sweeping away snow to reach the grass below. Ancient horses grazed beside them, different from modern horses, stockier and better built for the cold. Steppe bison, twice the size of modern buffalo. giant sloths, saber-toothed cats, American lions that would make today's African lions look like small models. It was a lost world, an entire ecosystem with no modern equivalent. And according to the traditional story, it was across this landscape that humans first entered the Americas. The people who made this journey were hunters, sophisticated, skilled, carrying technology that had been honed over thousands of years in Siberia. They weren't deliberately exploring or setting out to conquer new continents. They were simply following the food. When the mammoth herds moved, they moved. When the bison migrated, they followed. At some point, probably without even realizing it, some of these hunting bands crossed from Asia into Alaska. The earth looked exactly the same on both sides. The animals were the same. There was no border, no sense of stepping into a new world. Just more grassland, more game, more opportunity. For perhaps thousands of years, these populations remained in Alaska and Beringia, hunting and living much as they had in Siberia. But to the south, something was shifting. The ice sheets covering Canada were beginning to retreat, and as they melted, they opened a narrow corridor between the massive Cordilleran ice sheet covering the western mountains and the even larger Laurentide ice sheet covering most of central and eastern Canada. This ice-free corridor, stretching roughly along the eastern slopes of the Rocky Mountains, became the supposed gateway into the rest of the Americas, according to the traditional model. Once this path opened, about 13,500 years ago, hunters moved south quickly. And this is where the Clovis culture enters the story. Beginning in the 1930s, archaeologists started finding distinctive stone spear points across North America. These weren't crude tools. They were masterpieces of stone flaking technology. Each Clovis point was carefully crafted from high-quality stone, often transported from quarries hundreds of miles away. It featured a distinctive fluted base, where a flake had been meticulously struck from each side, creating a groove that allowed the point to be securely fastened to a wooden shaft. The craftsmanship was extraordinary. Creating a Clovis point required an intuitive understanding of stone fracture mechanics, planning each strike with precision, knowing exactly how much force to apply and at what angle. A single mistake could ruin hours of work. Yet these points were manufactured in such massive quantities that archaeologists have recovered thousands of them scattered across the continent. More importantly, they were found alongside mammoth kill sites, places where these ancient hunters had cornered and butchered the megafauna of the Ice Age. The evidence seemed clear. These were specialized big game hunters, following the mammoth herds across the landscape, armed with the most sophisticated hunting technology of their time. The theory was beautiful in its simplicity. Humans arrived about 13,000 years ago. They brought Clovis technology with them, or developed it shortly after arriving. They spread rapidly across 2 continents, following the herds, ultimately reaching the southern tip of South America in just a few thousand years. One migration, one technology, one founding population. It explained everything archaeologists were finding. The vast distribution of Clovis points, their relative uniformity across great distances. The timing that perfectly coincided with the opening of the ice-free corridor. Even the disappearance of many giant Ice Age species seemed to fit. Perhaps these hyper-efficient hunters had driven the mammoths and other large animals to extinction shortly after their arrival. For decades, this model dominated American archaeology. It was taught in every university. It was featured in every textbook. Museums built entire exhibitions around it. The Clovis First hypothesis wasn't just accepted. It was assumed as established fact. Any archaeological site claiming to be older than Clovis faced immediate skepticism. The burden of proof was immense. The dating had to be flawless. The artifacts had to be indisputable. The context had to be absolutely secure. Even then, most pre-Clovis sites were dismissed, sometimes without serious examination. This wasn't necessarily bad science. Extraordinary claims require extraordinary evidence, and there had been false alarms before. Sites that initially seemed ancient, but proved to be younger than expected. Artifacts that looked man-made, but turned out to be naturally fractured rocks. Dates contaminated by older carbon that made young sites appear ancient. Archaeologists had learned to be cautious, perhaps too cautious, because even at the height of Clovis orthodoxy, there were problems. Small anomalies that didn't quite fit the model. Sites in South America that seemed to date to the same period as Clovis, or even earlier. How could people have reached the southern tip of South America so quickly? Traditions of stone tools in certain regions that looked nothing like Clovis, suggesting different technologies or different populations. And perhaps most troubling, genetic studies of Native American populations that hinted at deeper, more complex origins. But these concerns were largely brushed aside or explained away. The ice-free corridor had opened about 13,500 years ago. Clovis appeared about 13,000 years ago. The timeline worked. The story made sense. Until it didn't. Because sometimes the most dangerous thing in science isn't being wrong. It's being so convinced you're right that you stop looking for the evidence that might prove otherwise. And in the case of the first peoples of America, that evidence was waiting to be found in ancient footprints in coastal caves, in the DNA of modern populations, in sites that predated Clovis by thousands of years. The traditional story was about to collapse, but it would take decades of controversial discoveries and bitter academic battles before anyone was truly ready to listen. For decades, the Clovis First model appeared solid. The dating was consistent. The artifacts were widespread. The logic was clear. Humans crossed Beringia 13,000 years ago, moved south through the ice-free corridor, and became the Clovis people. Case closed textbooks, written careers built on those foundations. But science doesn't care about consensus. It cares about evidence. And the evidence was beginning to whisper things no one wanted to hear. The first real crack appeared in 1977. Not in North America, where everyone was looking, but at the opposite end of the hemisphere in southern Chile, nearly 10,000 miles from the Bering Strait. Archaeologist Tom Dillahay began excavating a site called Monte Verde. What he found there would ultimately tear the Clovis theory to pieces. Monte Verde sits along a creek in the Chilean highlands, a quiet place where water and peat work together to accomplish something remarkable. They preserved an ancient campsite so completely that archaeologists could identify not just stone tools, but wooden artifacts, animal hides, and even fragments of wild potatoes and medicinal plants. The preservation was extraordinary, almost unprecedented. You could see where people had rebuilt shelters, where they had prepared food, where children had played near the water. But it was the dating that caused the real trouble. Radiocarbon dating placed the main occupation layer at 14,500 years ago. That is 1,500 years before Clovis, and 10,000 miles south of where the Bering Strait crossing would have deposited the first Americans. Do the math. If the Clovis people entered North America 13,000 years ago, How did these ancestors reach southern Chile 14,500 years ago? The numbers didn't add up. Unless humans had been in the Americas much, much earlier than anyone thought. The archaeological establishment didn't want to hear it. Dillahey was challenged at every step. Critics questioned his dating methods, his artifact identifications, his excavation techniques. Some suggested the wooden tools weren't tools at all, just pieces of wood shaped by water and time. Others claimed contamination had skewed the radiocarbon dates. The resistance was fierce, almost personal. But Dillahey kept working. He invited critics to visit the site, to examine the evidence for themselves. He published detailed reports, answered every challenge, refined his methods. And slowly, grudgingly, the evidence became impossible to ignore. In 1997, a special site visit by prominent archaeologists concluded that Monteverde was legitimate. Humans had indeed been there 14,500 years ago. The Clovis barrier had been broken. Except it wasn't just Monteverde. Once archaeologists started looking seriously at pre-Clovis possibilities, other sites stepped out of the shadows. Sites that had been dismissed or ignored because they didn't fit the accepted timeline. Sites that suddenly demanded re-examination. Take the Meadowcroft rock shelter in Pennsylvania, excavated in the 1970s by James Adovasio. This rocky overhang near Pittsburgh revealed layer after layer of human occupation reaching deep into the past. The deepest layers, where the oldest artifact appeared, dated back 16,000 years, perhaps more. The site was meticulously excavated, with careful stratigraphic control and multiple dating methods. Adovasio documented everything: stone tools, fire pits, plant remains, animal bones. The stratigraphy was clear, undisturbed, consistent. Everything suggested a continuous human occupation from the Ice Age right up to historical times. But 16,000 years ago was 3,000 years before Clovis. The archaeological community was not ready for that. Critics argued that coal deposits in the area could have contaminated the radiocarbon samples, making them appear older than they really were. But Adovasio had anticipated this. He had taken samples from materials unlikely to absorb ancient carbon, used multiple dating labs, and cross-referenced his results with different methodologies. The dates held firm. Yet, the controversy dragged on for decades. Even after Monteverde was accepted, Meadowcroft remained contested, pushed too far outside the comfort zone. Then there was the Topper site in South Carolina. Archaeologist Al Goodyear had been excavating there since the 1980s, finding a beautiful Clovis layer that fit the established timeline perfectly. But in 1998, he decided to dig deeper, just to see what lay beneath the Clovis horizon. What he found threw everything into question. Below the Clovis layer, separated by sterile sediments, lay another layer of what appeared to be stone tools. Thousands of them. Flakes, blades, possible points. And the dating suggested they were 50,000 years old. 50,000 years. That wasn't just pre-Clovis. That was before modern humans had even left Africa in the accepted timeline. That was contemporary with Neanderthals in Europe. The response was predictable. Most archaeologists simply refused to entertain the idea. The artifacts weren't really tools, they said, just rocks broken by natural processes. The dating must be wrong. The stratigraphy must be confused. Anything but the possibility that humans were in South Carolina 50,000 years ago. Goodyear expected the skepticism. He even understood it. Extraordinary claims require extraordinary evidence. But he kept digging, kept dating, kept documenting. The evidence wasn't going to vanish just because people didn't want to believe it. But perhaps the most compelling pre-Clovis evidence came from an unlikely source. Not stone tools, not campsite remains, but human waste. In the Paisley Caves of south-central Oregon, archaeologist Dennis Jenkins found something that couldn't be easily dismissed or reinterpreted. Coprolites, fossilized human feces dating back 14,300 years. Coprolites might not sound glamorous, but they are archaeological gold. Unlike stone tools, which critics can argue are natural formations, or wooden artifacts that can be questioned as contamination, coprolites are unambiguous. They are distinctly human. And the ones from Paisley Caves contained human DNA confirmed by genetic analysis. Not just any DNA, but distinctly Native American genetic markers. These weren't Clovis people. They were their predecessors living in North America more than 1,000 years before the Clovis culture appeared. The coprolites also contained plant and animal remains that offered a window into the diet of these populations. They were eating fish, waterfowl, small mammals, and a variety of plant foods. They knew the landscape, understood seasonal availability, and possessed the knowledge necessary to survive in the high desert environment of Ice Age Oregon. This wasn't a brief visit or an accidental presence. This was an established occupation by people who knew exactly what they were doing. The DNA evidence was particularly significant. Critics could challenge the identification of stone tools or debate radiocarbon dates. But genetic material doesn't lie. These samples weren't contaminated by modern DNA. They showed a clear ancestry tied to Native American populations, and they were definitively 14,300 years old. The dating was verified with multiple methods. The genetic analysis confirmed by independent labs. It was solid, undeniable proof of a pre-Clovis human presence in North America. But why did it take so long for these sites to be accepted? Why the decades of resistance, the dismissals, the career-damaging controversies? Part of the answer lies in simple scientific conservatism. Any established theory develops a kind of momentum, an institutional weight that is hard to overcome. Researchers build careers on the accepted model. Textbooks are written. Museum exhibits are designed. Academic reputations are invested in the status quo. Challenging that requires not just good evidence, but overwhelming evidence. Evidence so strong it cannot be ignored or explained away. There was also a methodological problem. Pre-Clovis sites are inherently harder to identify and interpret than Clovis sites. They are older, more weathered, less well preserved. The artifacts are often simpler, harder to distinguish from naturally broken rocks. Dating becomes trickier as you push back beyond the reliable range of radiocarbon methods. Every extra layer of uncertainty gives critics more ammunition, more reason to remain skeptical. And honestly, some of the early claims of pre-Clovis occupation were poorly supported. Over-enthusiastic researchers, seeing artifacts in natural rock formations, misinterpreting stratigraphic sequences, contaminating radiocarbon samples. These false alarms made the legitimate discoveries harder to accept. The archaeological community had been burned before. It wasn't eager to be burned again. But by the early 2000s, the weight of the evidence had become impossible to ignore. Monte Verde was accepted. Paisley Caves provided genetic confirmation. Even the most skeptical researchers had to admit that something was wrong with the Clovis First model. Humans had been in the Americas before Clovis. Maybe not 50,000 years before, as Topper suggested, but certainly 14 to 16,000 years before the present. It was an established fact, and it raised an entirely new set of questions. If people were here before Clovis, who were they? Where did they come from? How did they get here? The ice-free corridor would not have been passable 14,500 years ago. The glaciers were still at their maximum extent, blocking any overland route from Beringia into the heart of North America. So how did the people at Monteverde reach Chile? How did the populations at Paisley Caves get to Oregon? And perhaps most intriguingly, why did these earlier populations leave such a faint archaeological signature? Clovis sites are everywhere once you know what to look for. Distinctive points, consistent tool-making techniques, wide distribution. But pre-Clovis sites are rare, scattered, difficult to identify. Were these earlier populations simply much smaller? Did they use different technologies that preserve poorly or are harder to recognize? Or were they fundamentally different types of people, practicing different ways of life, representing perhaps even different waves of migration? The cracks in the timeline had revealed something unexpected. The story of the first Americans was not simple. It wasn't a single crossing, a single people, a neat and tidy narrative. It was messy, complicated, full of gaps, mysteries, and possibilities that challenged everything researchers thought they knew. And the evidence was about to get even stranger. So, let's go back to those footprints. But this time, we are going to slow down. We are going to really look at what they represent, what they tell us, and why they have completely upended everything we thought we knew about American prehistory. Imagine White Sands, New Mexico, 23,000 years ago. But this is not the desert you see today. Back then, at the height of the last ice age, it was a completely different place. Where you now have gypsum dunes and scrub brush, there was a massive lake. Lake Otero, fed by glacial meltwater coming down from the mountains. The shoreline stretched for miles, a rare oasis in an otherwise cold and unforgiving landscape. The Ice Age hadn't turned the Southwest into a uniform deep freeze. No mammoths grazing on frozen tundra here. Instead, temperatures were cooler than today, perhaps 10 to 15 degrees Fahrenheit lower. The landscape was a mix of grasslands punctuated by stands of pine and spruce. And around the edges of the lake, where the water met the land, there was mud. Lots of mud. The kind of soft, wet sediment that preserves footprints beautifully. People came here. Not just once or twice, but regularly. They came to hunt the giant ground sloths that browsed the vegetation. They came to fish in the shallow waters. They came to gather seeds and roots from the plants thriving in the wetland environment. And as they walked along the muddy shores, they left their marks. A woman, probably in her 20s, based on the size of her foot, walking south along the beach. Her footprints show a steady, purposeful stride. She isn't running, she isn't hunting. She is simply traveling, perhaps heading toward another group, perhaps checking traps, or just walking, the way humans have walked for hundreds of thousands of years. Beside her tracks are smaller ones, a teenager, by the looks of it, keeping pace with the adult. Not the hesitant step of a child, but the longer stride of someone stepping into adulthood. Were they a mother and daughter? An aunt and niece? A teacher and student? We will never know, but they were together, walking the same path at the same time. And then there are the children. Oh, the children. Their footprints are everywhere in the white sands trackways. Little footprints, running, jumping, playing. Sometimes they run in circles, like kids chasing each other. Sometimes they show signs of slipping in the mud, the kind of mess that would have made their parents shake their heads. One trackway shows what must have been a toddler, maybe 5 or 6 years old, making a long journey across the mudflats. But he wasn't alone. A larger set of prints, an adult, appears periodically alongside the child's tracks. The pattern suggests the adult was watching over the kid, making sure he was okay, then stepping away to do something else, then coming back to check. It's parenting. 23,000-year-old proof of an adult keeping an eye on a child as he explored. The footprints themselves are remarkably well preserved. You can see the impressions of the toes, the curve of the arch, and sometimes even the way the weight shifts from heel to toe during the stride. These are not vague depressions. They are detailed records of individual human beings, of their anatomy, their movement patterns, and even hints about their behavior and relationships. But here is what makes such preservation possible. The timing had to be perfect. People walk on the wet mud by the lake. Within a few hours, maybe a day or two, the mud dries slightly in the sun and wind, hardening just enough to hold the shape. Then, before erosion can destroy the tracks, another layer of sediment settles over them. Maybe the lake level rises temporarily. Maybe a storm blows in fine sand. Maybe nearby springs overflow. Whatever the cause, the footprints are buried and protected. This cycle repeats over and over. Walk, harden, bury. Walk, harden, bury. Layer upon layer of footprints, separated by thin bands of sediment, building up over hundreds, even thousands of years. Eventually, the entire sequence is buried deep enough to be shielded from erosion for millennia. What we see today is only visible because modern erosion has started to uncover these ancient layers. The wind scours away the overlying sediments, revealing track surfaces that haven't seen the light of day since the Ice Age. If researchers hadn't found them exactly when they did, wind erosion would have destroyed them in a matter of years. This is where it gets truly fascinating. These sediment layers that buried and preserved the footprints contained seeds, specifically seeds from aquatic plants that grew in and around Lake Otero, mainly ditchgrass seeds. Rupia serosa, a plant that thrives in shallow wetlands and brackish waters. Seeds are made of organic matter. Organic matter contains carbon, including the radioactive isotope carbon-14. Every living thing on Earth absorbs carbon-14 from the atmosphere during its life. But the moment something dies, that process stops. The carbon-14 begins to decay at a predictable rate, with a half-life of about 5,730 years. Measure the amount of carbon-14 left in an organic item, and you can calculate exactly when it died. Researchers collected dozens of these seeds from the sediment layers situated just above and below the footprint horizons. They sent them to multiple radiocarbon dating laboratories to ensure accuracy and reproducibility. Then they waited for the results. The dates came back, and they were shocking. 21,000 years ago. 22,000 years ago. Some footprint layers went all the way back to 23,000 years ago. Let that sink in for a moment. 23,000 years ago is not slightly older than Clovis. It is not just a little bit before the ice-free corridor opened. It is nearly 10,000 years before the Clovis culture appeared. It is during the last glacial maximum, the absolute peak of the Ice Age, when glaciers covered most of Canada and the northern United States, with ice sheets reaching 2 miles thick. The Cordilleran ice sheet blanketed the Rocky Mountains and the Pacific Northwest. The Laurentide ice sheet covered everything from the Atlantic coast to the eastern edge of the Rockies. Between the two, for most of the last glacial maximum, there was no corridor, no passage, no way through. The ice sheets merged, creating an impenetrable wall of frozen water stretching from ocean to ocean. And yet there were humans in New Mexico, living their lives, raising their children, hunting giant sloths, walking along the shores of the lake. And this wasn't just a brief passing through. The multiple layers of footprints, spanning thousands of years, suggest a repeated, enduring occupation. These weren't lost explorers who accidentally stumbled into the Americas and vanished. This was a viable population surviving and thriving in Ice Age America, while the glaciers completely blocked the traditional route of entry. The reaction from the scientific community was predictable. Skepticism, bordering on disbelief. Radiocarbon dating isn't perfect, the critics pointed out. Maybe the seeds were contaminated. Maybe they were older than the footprints and somehow got mixed in. Maybe the dates were simply wrong. So the researchers went back. They collected more seeds. They dated more layers. They used multiple dating methods. They brought in outside experts to verify their techniques. Every single test confirmed the initial findings. The footprints were authentic. The dates were accurate. Humans were in the Americas during the last glacial maximum. Some researchers tried to argue that the ice-free corridor might have opened briefly during this period, just long enough for people to slip through. But glaciologists quickly dismissed that idea. Ice core data, geological evidence, climate reconstructions. Everything confirmed that the corridor was hermetically sealed from roughly 26,000 to about 14,000 years ago. There was no brief opening. There was absolutely no way through. Others suggested that populations might have come before the glaciers merged and then found themselves trapped south of the ice sheets. But that creates its own set of problems. Genetic data shows that the ancestors of Native Americans were living in Beringia, the land connection between Siberia and Alaska, precisely during this time. They weren't isolated south of the ice sheets. They were still connected to Asian populations. The DNA doesn't lie. The implications are staggering. If people were in New Mexico 23,000 years ago, they had to get there somehow. And if the ice-free corridor was closed, there is only one other option. They came down the coast, not overland and through Canada, but along the Pacific shoreline, possibly using boats, staying in coastal refuges where the glaciers hadn't quite reached the ocean. This completely changes the story. The traditional narrative presents humans as terrestrial big game hunters, following mammoths and bison through the ice-free corridor. But coastal populations would have been something entirely different. Maritime adapted peoples, experts in boat building and hunting marine mammals, harvesting shellfish and fishing in the rich waters of the Pacific Rim. A completely different survival strategy. A completely different culture. And that raises even more questions. How long had populations been using this coastal route? If they were in New Mexico 23,000 years ago, when did they first arrive? Were there earlier migrations for which we simply haven't found the evidence yet? How many waves of migration were there? The White Sands footprints don't answer these questions. What they do is prove beyond any reasonable doubt that the traditional story is wrong. Humans did not first enter the Americas 13,000 years ago through an ice-free corridor. They were here much earlier, arriving by routes we are only just beginning to understand. These footprints, these simple impressions in the ancient mud, they aren't just evidence. They are a revolution. They have forced archaeologists to reconsider everything they thought they knew about the peopling of the Americas. And they have opened up possibilities that once seemed impossible. Alternative routes, older dates, different histories of migration. But here is the most beautiful part. These footprints are also deeply, profoundly human. They show us people living their lives, completely unaware that they were doing anything remarkable. They didn't know they were pioneers. They didn't know they were proving anything to anyone. They were just walking along the shore of a lake, watching their children play, going about the daily business of survival in a world that must have seemed strange, dangerous, and magnificent all at once. 23,000 years later, we can still see where they walked. We can measure the length of their stride, estimate their height, imagine their lives. And in doing so, we are connected across an almost incomprehensible expanse of time to people who were fundamentally exactly like us. Human beings making their way in an uncertain world, leaving marks that would last far longer than they could have ever imagined. But what if we've been looking in the wrong place all along? What if the first Americans didn't walk across a frozen tundra at all? What if they sailed? Imagine the Pacific coast during the last ice age. Not the coast you know today with its beaches and port cities, but the ancient coastline as it existed 15,000 years ago. Sea levels were 400 feet lower than they are now. All that water was locked up in the continental ice sheets. The shoreline extended for miles beyond the modern beach, creating a vast shelf of exposed land that stretched from Alaska down to California and beyond. And along this entire expanse lay something extraordinary. An underwater forest so dense, so rich in life, that it created a marine highway stretching for thousands of miles. The Ice Age kelp forests of the Pacific. If you have ever seen a kelp forest, you know they aren't really forests in the traditional sense. They are underwater jungles of giant brown algae that can grow 2 feet a day, rising from the seafloor to create dense canopies at the surface. Each kelp plant becomes its own ecosystem, sheltering hundreds of species of fish, invertebrates, and marine mammals. During the Ice Age, these forests were even more extensive than they are today. The exposed continental shelf created perfect conditions for kelp to grow. Shallow waters, rocky substrates, nutrient-rich currents welling up from the deep. From what is now Alaska, down the coast through British Columbia, Washington State, Oregon, California, all the way to Mexico and beyond, the kelp forests thrived. And they were teeming with food, not just teeming, but absolutely overflowing with calories just waiting to be harvested. Sea otters paddled through the kelp fronds, so numerous that some scientists believe Ice Age populations must have been 10 times larger than today's depleted numbers. Seals and sea lions hauled out on the rocky shores to breed and rest. Fish swarmed in massive schools. Salmon, rockfish, halibut. Shellfish carpeted the intertidal zones. Mussels, clams, sea urchins, abalone. And within the kelp forests themselves, octopuses, crabs, and thousands of other edible species. For a people who understood this environment, who had developed the skills to exploit maritime resources, this coast would have been a paradise, not a barrier to cross, but a highway to follow, a protein-rich corridor that led from Asia to the Americas, without ever having to venture into the frozen interior. This is the Kelp Highway hypothesis. The idea that the first Americans were seafaring specialists who followed the Pacific coast southward from Asia, island hopping across the Bering region when it was a complex archipelago rather than a solid land bridge, and then continuing down the coast in boats. It sounds radical, but the more we look at the evidence, the more sense it makes. Consider the timeline problem. The White Sands footprints date back 23,000 years, but the ice-free corridor through Canada didn't open until about 14,000 years ago. For people to reach New Mexico that early by land, they would have had to somehow navigate across or around massive ice sheets. But along the coast, the way was always clear, even during the coldest depths of the Ice Age. The Pacific coastal route remained mostly ice-free, kept temperate by ocean currents. Consider the skills required. We have always assumed the first Americans were big game hunters, following mammoths and bison. But what if they were fishermen? What if they were a people who had spent thousands of years perfecting maritime technologies along the Asian coastlines? The archaeological evidence for this is frustratingly scarce, but that is exactly what you would expect if people had lived primarily along a shoreline that is now 400 feet underwater. Think about that for a moment. Every coastal camp, every shell midden, every beach where ancient Americans launched a boat, prepared a fish, or taught their children to swim. Everything has vanished, drowned when the ice sheets melted and the sea levels rose. The entire archaeological record of coastal adaptation has been buried under hundreds of feet of ocean. We aren't looking for a needle in a haystack. We are looking for a needle in a haystack that has been submerged for 10,000 years. But there are clues. Places where ancient sites survived because they were on islands that stayed above water even as the sea levels rose. And one of the most remarkable is the Channel Islands archipelago off the coast of California. Today, the Channel Islands are separated from the mainland by miles of ocean. But during the Ice Age, sea levels were so much lower that the northern four islands formed a single massive landmass called Santa Rosa. And on this island lived something that shouldn't have been possible to reach: pygmy mammoths. These weren't full-sized mammoths. They were miniature versions that had evolved in isolation on the island, standing only about 6 feet tall at the shoulder. And humans were hunting them. Archaeological sites on the Channel Islands contain mammoth bones with butchery marks dating back at least 13,000 years. But here is the crucial detail. Even at the lowest sea levels, Santa Rosa was still separated from the mainland by about 5 miles of open ocean. These people didn't walk or wade to the island. They sailed, with enough boats and enough confidence in their seafaring skills to transport entire communities across open water just to hunt pygmy elephants. This wasn't primitive technology. It was sophisticated navigation. And there is more evidence coming from even further across the Pacific. In Japan, the Jomon culture developed one of the most elaborate maritime adaptations in the ancient world. 16,000 years ago, they were building sophisticated boats, crafting fishhooks from bone and shell, and developing ceramic technology to process marine resources. Some of their sites show evidence of deep-sea navigation. They were reaching islands that required crossing dozens of miles of open ocean. They understood currents, winds, and navigation. They had developed a complete maritime toolkit that would have made coastal migration not just possible, but relatively straightforward. Could similar technologies have existed along the Asian coast even earlier? Could groups of maritime specialists have followed the kelp forests and coastal resources from Asia to the Americas thousands of years before anyone thought to look for them inland? Genetic evidence is beginning to suggest exactly that. Some Native American populations possess genetic markers that are more closely linked to the coastal populations of Asia than to inland groups. This implies their ancestors might have followed a coastal route rather than traversing the interior. But finding hard proof is almost impossible. Underwater archaeology is expensive, time-consuming, and technically formidable. You can't just wander around looking for artifacts the way you can on land. You need sonar submersibles, remotely operated vehicles. You need to know exactly where to look in an ocean that has been rearranging sediment for 10,000 years. Despite these challenges, some teams are trying. Off the coast of British Columbia, archaeologists are using the traditional knowledge of First Nations peoples to identify promising underwater locations. These indigenous communities hold oral histories of places that were once above water. Ancient village sites now submerged. In some spots, they have found artifacts, stone tools emerging from the underwater sediments, wooden stakes that might be the remnants of ancient fish weirs. Nothing definitive yet, but tantalizing hints of what might lie beneath. Off the California coast, other teams are using high-resolution sonar to map the submerged continental shelf, looking for features that might indicate human habitation. River mouths that would have been attractive settlement sites, shallow areas where kelp forests would have thrived, natural harbors protected from the surf. Every now and then, they find something interesting. An unusual concentration of rocks that could be a fish trap. A linear feature that might be a canoe launch. But confirming these as archaeological sites requires direct investigation, and that means expensive diving operations in conditions that are often dangerous. It's like trying to excavate a site while wearing a spacesuit in zero gravity. Everything takes 10 times longer and costs 100 times more than terrestrial archaeology. But what if they find definitive proof? What if, somewhere off the coast of Alaska or British Columbia, archaeologists uncover an intact settlement preserved by cold water and buried sediment? A site with boats, fish processing areas, maritime tools, and perhaps even organic remains that could be dated. It would rewrite everything we think we know about the peopling of the Americas. The first Americans would instantly shift from intrepid mammoth hunters braving frozen wastes to skilled mariners navigating one of the richest ecosystems on Earth. The journey to the Americas wouldn't be a desperate trek across a hostile tundra, but a gradual expansion along a familiar coastal environment, quite similar to what they had known in Asia. It would also explain how people reached South America so quickly. By following the coast, you could travel from Alaska to Chile in a matter of years, or decades, not millennia. No need to adapt to new inland environments to learn new hunting techniques, or to devise new survival strategies. You just had to keep following the kelp forest south, harvesting familiar resources, stopping to establish camps in particularly productive spots. Some groups could have moved inland from this coastal highway following rivers into the heart of the continent. Others might have stayed on the coast for generations, developing increasingly specialized maritime adaptations. The diversity of the earliest American cultures might reflect these different strategies, coastal specialists and inland hunters diverging from a common seafaring ancestry. But until we find those underwater sites, until we can actually excavate and study the remains of coastal camps, the Kelp Highway remains a compelling hypothesis, well argued. supported by circumstantial evidence, but still unproven. The ocean guards its secrets well. And the first Americans, if they were indeed maritime peoples, left their most important archaeological sites in the one place we can barely reach. 400 feet down, buried beneath millennia of sediment, waiting for technology funding and luck to align. Somewhere out there, beyond the breakers and beneath the kelp forests that still thrive along the Pacific coast, the proof might be waiting. Ancient boats preserved in anoxic mud, fishing camps frozen in time, the evidence that would transform our understanding of human migration and seafaring capabilities forever. But there is another theory, one even more controversial than coastal migration. A theory suggesting the first Americans might not have come from Asia at all. This is where things get truly bizarre, contentious, and politically charged, in ways that have nothing to do with science, and everything to do with modern identity politics. Some archaeologists have proposed something that sounds absolutely insane at first glance. What if the first Americans didn't come from Asia at all? What if they came from Europe? Crossing the Atlantic Ocean during the Ice Age, 21,000 years ago. This is known as the Solutrean hypothesis, and it rests on a simple, undeniable, and deeply unsettling observation. Some of the oldest stone tools found in North America look remarkably like the tools made by the Ice Age inhabitants of France and Spain. Not vaguely similar, almost identical in some cases. Let me paint the picture for you. The year is 21,000 years ago in southern France. A group of people we call the Solutreans is living through the last glacial maximum, the absolute coldest stretch of the last ice age. They have developed a distinctive technology, a method of making stone tools that looks like nothing else in the world at that time. They craft these beautiful laurel leaf-shaped points, thin, symmetrical, pressure-flaked with unbelievable skill. Some are so delicate and fragile they could never have been used as weapons. They are pieces of art, displays of craftsmanship, possibly ritual objects. These Solutrean tools appear about 22,000 years ago and last until roughly 17,000 years ago. Then the tradition vanishes, replaced by other technologies as the climate warms and cultures shift. Now let's jump across the Atlantic to North America, about 13,000 years ago. Suddenly, across the continent, a new tool technology appears. Clovis points. Beautiful, symmetrical, fluted projectile points with distinctive grooves running up from the base. They are made using sophisticated pressure flaking techniques. And to some archaeologists, they look suspiciously like those Solutrean points from France. Not identical, but similar enough to suggest a connection. The flaking patterns, the symmetry, the careful preparation of the stone cores the overall aesthetic. Could it be a coincidence? Could two completely separate populations on opposite shores of the ocean independently develop nearly identical stone flaking techniques? Of course, convergent evolution happens in technology, just as it does in biology. There are only so many ways to make an effective spear point, after all. But proponents of the Solutrean hypothesis say the similarities are too specific, too detailed to be blind luck. They argue there had to be contact, that somehow people from Ice Age Europe reached North America thousands of years before the Clovis culture emerged. Here is how they imagine it might have happened. During the last glacial maximum, so much water was locked up in glaciers that sea levels dropped by more than 400 feet. But that isn't the most important part. The most important part is the ice itself. The Atlantic Ocean was partially frozen, not solid ice from shore to shore. But there was a massive ice shelf extending from Greenland all the way down to the edge of what is now the Canadian Maritimes. This ice edge created a unique ecosystem, a narrow zone where the ocean met the glacier, where seals hauled out on the ice to give birth, where seabirds nested, where fish gathered in the cold, nutrient-rich waters. The Solutrean hypothesis suggests that European hunters, people already adapted to Arctic conditions, began exploiting this Ice Age environment, following the seals living on the ice during the summer months, much like Inuit peoples would do millennia later. Perhaps at first they only ventured a few miles offshore, then a few dozen miles, generation after generation, pushing further along the edge of the ice, always following the seals and seabirds that provided their food. Eventually, perhaps, over hundreds or thousands of years, some of these groups might have reached the coast of North America. Not through a conscious voyage of exploration, but just a gradual, creeping expansion of their territory along a continuous Ice Age habitat that stretched from Europe to America. It actually isn't as crazy as it sounds. We know the Inuit have traveled enormous distances across the Arctic sea ice. We know Norse sailors reached North America around the year 1000, using boats far more primitive than we tend to think. We know humans are capable of incredible feats of navigation and survival in extreme environments. And proponents of the Solutrean hypothesis can point to intriguing evidence beyond just stone tools. Some of the pre-Clovis sites on the North American East Coast, places like Cactus Hill in Virginia and Miles Point in Maryland, have yielded tools that look more European than Asian in their construction technique. There are also skeletal remains from early North America that show physical traits more common in European populations than in Asian ones, though this evidence is highly contested and controversial. So why don't most archaeologists accept this hypothesis? Why is it relegated to the fringes of the discipline, discussed in hushed tones at conferences, treated almost as heresy by mainstream researchers? The answer is simple: genetics. When scientists began analyzing the DNA of ancient Native American remains, they found exactly what you would expect if the Americas had been populated from Asia. The genetic markers match populations from East Asia and Siberia. Ancient Native Americans carry the genetic signatures of people who lived near the Bering Strait, of groups who migrated through Beringia. What they do not carry is European DNA. No genetic proof of Solutrean ancestry. No markers from Ice Age European populations. Nothing. If there had been a significant migration from Europe to America 21,000 years ago, we should see European genetic markers in Native American populations, even if they were faint, even if they had been mostly diluted by subsequent Asian migrations. But we don't. The genetic evidence is crystal clear. The ancestors of Native Americans came from Asia, not Europe. Proponents of the hypothesis have tried to explain this away. Maybe the European migrants died out before they could pass on their genes. Maybe they were completely replaced by later Asian arrivals. Maybe they were just too small a population to leave a lasting genetic signature. But these explanations require increasingly improbable scenarios. We are asked to believe that Europeans arrived in America, survived long enough to establish Clovis technology across the entire continent, but then vanished completely without leaving a single genetic trace. That is a lot of coincidences stacked on top of one another. There is also the timeline problem. The Solutrean culture in Europe vanished about 17,000 years ago. The Clovis culture in America appears about 13,000 years ago. There is a 4,000-year gap. If Clovis technology came from Solutrean migrants, where was it during those 4,000 years? Why don't we find Solutrean-style tools dating to that intermediate period? Most mainstream archaeologists now believe that the similarities between Solutrean and Clovis tools are either a coincidence or the result of basic principles for designing an effective stone tool. There are only so many ways to make a good spear point. If you are working with the same materials and solving the same problems, you might arrive at similar solutions, even if you are on the other side of the ocean. But here is where it gets uncomfortable. The Solutrean hypothesis has become entangled with modern politics in a way that has absolutely nothing to do with real archaeological evidence. Certain people have latched onto it because they like the idea that Europeans were in America first, that European ancestry can lay claim to some sort of primacy in the Americas. It has made the entire subject toxic, radioactive. Archaeologists who even mention the Solutrean hypothesis risk being accused of pushing a political agenda, of trying to undermine Native American claims of being the continent's first inhabitants. It's a shame, because it means a potentially interesting scientific question cannot be examined dispassionately. Maybe the Solutrean hypothesis is completely wrong. The genetic evidence certainly suggests that it is. But the fact that it has become so politically charged means researchers are often reluctant to even discuss it, which is not how science is supposed to work. The controversy reveals something important about archaeology in the 21st century. The past is never just the past. It is constantly being used to justify present-day claims about identity, ownership, and belonging. Who was here first matters to people today in ways that shape politics, law, and culture. Native American tribes rightly view attempts to prove European primacy in the Americas as attacks on their heritage and sovereignty. European nationalists view the Solutrean hypothesis as a validation of their own importance. Archaeologists are caught in the middle, trying to do science while navigating these political minefields. The truth, as usual, is probably far more complicated than any single hypothesis. The peopling of the Americas likely involved multiple migrations in multiple directions over thousands of years. The genetic evidence heavily supports an Asian origin for the vast majority of Native American ancestry. That doesn't mean there couldn't have been earlier, failed colonization attempts from other directions. Those earlier groups might have left stone tools, but no descendants. Or maybe the similarities between Solutrean and Clovis tools really are just a coincidence. Perhaps ancient toolmakers, working independently on opposite shores of the ocean, discovered the same effective techniques through trial and error and practical experience. What we can say with certainty is that the Solutrean hypothesis, as originally proposed, does not stand up to genetic scrutiny. Native Americans descend from Asian populations, not European ones. The DNA doesn't lie. But the controversy surrounding this hypothesis teaches us something valuable about how archaeology functions in the modern world. Every discovery, every theory, every interpretation is filtered through contemporary concerns about identity and politics. The past can never be purely objective because we always view it through the lens of the present. And sometimes the most interesting thing about a controversial theory isn't whether it's true or false, but why it stirs up so much passion in the first place. What it reveals about what people want to believe about the stories we tell ourselves about who we are and where we come from. By the time those first footprints were pressed into the mud at White Sands, the world was already populated with ghosts. Not the supernatural kind, but the genetic kind. Inside every single person listening to this, tucked quietly away in your chromosomes, are fragments of DNA that don't belong solely to Homo sapiens. Little sequences of code that come from other kinds of humans, Neanderthals, Denisovans, and perhaps, if the most controversial evidence is right, groups of humans we haven't even named yet. For most of the 20th century, the story was simple. There was us modern humans. Before us, there were other hominids like the Neanderthals. We replaced them. End of story. Then geneticists started pulling DNA out of ancient bones, and the story fell apart. When researchers sequenced the Neanderthal genome in the early 2000s, they expected to find a completely separate branch, a dead end with no survivors. Instead, they found something unsettling. The Neanderthals hadn't vanished. They were inside us. Anyone of non-African descent alive today carries roughly 1 to 2% Neanderthal DNA. Not as a fossil, not as a relic, but as living, functioning genes that influence things like your immune system, your skin, and even how you react to certain diseases. Indigenous peoples of the Americas share this same Neanderthal signal, inherited from ancestors who encountered Neanderthals in Eurasia long before anyone ever crossed into the New World. That was the first revelation. Then came the second, even stranger one. In an isolated cave in Siberia, called Denisova Cave, archaeologists found a single finger bone, just a fragment of a pinky from a girl who lived over 50,000 years ago. They expected it to belong to a Neanderthal. The cave had already yielded Neanderthal remains. It made sense. But when they sequenced the DNA, it wasn't Neanderthal, and it wasn't modern human. It was something else. A sister species to Neanderthals, closely related, but distinct. A branch of humanity no one had ever seen before. They named them after the cave, the Denisovans. For a time, Denisovans were almost like a rumor. A handful of teeth, a jaw fragment from Tibet, a piece of a skull. No complete skeleton, no reconstructed face, just scattered bones and a flood of genetic data. But that DNA told an incredible story. Denisovans had been widespread across Asia, from Siberia all the way to Southeast Asia, for hundreds of thousands of years. They weren't a fringe group, they were major players. And just like Neanderthals, they had children with our ancestors. Today, people in Asia and Oceania carry Denisovan DNA. Indigenous Australians, Papuans, and certain indigenous groups in the Philippines can have 4 or even 5% Denisovan ancestry. East Asians, Polynesians, and Native Americans have smaller amounts, but it is still there. Which means something strange. The ancestors of the indigenous peoples of the Americas were already carrying Denisovan genes before they even reached Beringia, before they ever saw mammoths grazing on the ancient Alaskan plains. Fragments of a vanished human species entered the Americas, tucked inside the bodies of the first modern humans to arrive. A Denisovan-derived gene helps people adapt to life in the thin air of the high Tibetan plateau. In Melanesia, Denisovan genes tune the immune system to handle new pathogens. In the Americas, the legacy is more subtle. Tiny shifts in metabolism, immunity, and cold adaptation. All of it silently inherited from encounters that took place a world away, long before those first footprints in the American sand. So when we ask who the first Americans were, the answer is already complicated. Even if the very first people here were fully modern Homo sapiens, they weren't genetically pure. They were mosaics, part Homo sapiens, part Neanderthal, part Denisovan. But there is a deeper, more unsettling question. What if the first Americans weren't fully modern humans at all? What if, long before our species set foot here, other humans had already come and gone? We are now entering the realm of the possible and the highly controversial. If Denisovans spread across Asia, if some of them had learned to cross open water to reach the islands of Indonesia and perhaps beyond, it is natural to wonder, could a group of Denisovans or other archaic humans have reached the Americas tens of thousands of years before modern humans arrived? We don't have a Denisovan skull from Alaska. We don't have a Neanderthal tool from California. Archaeology, as it stands right now, gives us no confirmed archaic human campsites in the Americas. But genetics hints at something strange. When scientists analyzed ancient and modern DNA from Native American and Siberian populations, they found signals that didn't match Neanderthals or Denisovans or any known group. They called them ghost populations, not because they were magical, but because they existed only as faint genetic shadows with no bodies attached, the signature of interbreeding with an unknown human lineage somewhere deep in Eurasian prehistory. One study suggested that some Amazonian groups carry a tiny fraction of ancestry linked to a mysterious population that split off from other non-African humans extremely early, perhaps 40 or 50,000 years ago. Another line of research highlights multiple waves of population mixing in Siberia, involving groups we have never directly sampled. These ghost populations could be deeply divergent branches of Homo sapiens. They could be relatives of the Denisovans. They could be entirely separate archaic humans that we simply haven't found yet. Whatever they were, their genes traveled. Some of them ended up in the ancestors of Native Americans. So inside the genomes of people living in the Amazon, the Arctic, the Great Plains, there may be echoes of strangers whose faces we have never seen, whose bones we have never held, whose tools we have never unearthed. If ghosts are written into the DNA of the people who eventually reached the Americas, could these ghostly humans have been here first? This is where archaeology tries to step in, and where things get highly contentious. Take a place called the Cerruti Mastodon site in California. In the 1990s, highway crews were widening a road and accidentally exposed the bones of a mastodon, one of those elephant-like animals that roamed Ice Age North America. The site was carefully excavated and then largely forgotten. Decades later, a team of researchers re-examined the material with fresh eyes. They noticed strange patterns. Heavy bones and teeth seemed to have been deliberately smashed, as if someone had hammered them to get at the marrow inside. Large stones nearby looked suspiciously like anvils and hammerstones. In 2017, the team published an earth-shattering claim based on uranium series dating of the bones. They argued that humans, or at least some kind of hominid, had been at this site approximately 130,000 years ago. Not 13,000, 130,000, if that date is accurate. It blows up almost everything about the peopling of the Americas. It would mean someone reached California more than 100,000 years before Clovis, long before the Bering Land Bridge migration, on which most models rely. Long before the presence of modern humans is solidly documented in East Asia. Who could these toolmakers have been? Modern humans pushing much earlier into the New World than we ever imagined. Neanderthals wandering through a frozen Arctic corridor. Denisovans extending their mysterious territory across the Pacific. or some other entirely vanished archaic human? The paper never answered that. It just pointed to shattered bones, fractured in ways the authors insisted matched human activity on stone anvils, rather than natural crushing by sediment or heavy machinery. The reaction from the scientific community was skeptical, to put it mildly. Critics pointed out that rocks can also break bones through natural processes. Heavy machinery at the construction site could have disturbed the layers. No actual stone tools were found, only battered cobbles that might be completely natural. And most importantly, there is zero corroborating evidence from this time period anywhere else in the Americas. No campsites, no fire pits, no butchered animal bones from other locations. If hominids were truly roaming California 130,000 years ago, where are they? In Alaska, in the Yukon, in Siberia? Why does the trail begin and end at one single, highly debated site? For now, the Cerruti mastodon remains a tantalizing anomaly. A possibility. A maybe. That is just enough to keep people awake at night, picturing Neanderthals standing beneath the California stars. But it is far from an accepted fact. And Cerruti isn't the only site to whisper the idea of an impossibly ancient human presence. Far to the south, in central Mexico, lies another enigmatic place, Hueyatlaco, near the modern city of Puebla. In the 1960s, archaeologists there excavated stone tools, blades and scrapers that seemed unmistakably man-made, in layers associated with extinct animals. When they tried to date the site, the results were shocking. Some methods suggested the tools were over 200,000 years old. Others pointed to around 250,000 years. Even the most conservative estimates placed them at over 100,000 years old. If true, Hueyatlaco would mean hominids were living in central Mexico long before Homo sapiens were known to have spread widely across Eurasia. Long before any accepted migration to the Americas. It would force us to consider pre-sapiens explorers, crossing oceans, or ancient land bridges we haven't entirely modeled. The response, once again, was a sharp dismissal. Many geologists argued the dating was flawed. The layers had been disturbed, or that younger tools had slipped down into older sediments. Others pointed out inconsistencies in the stratigraphy, the way the layers were stacked. The archaeologists who ran the excavation stood by their findings. But the controversy grew so bitter that work at the site essentially ground to a halt. For decades, Hueyatlaco has hovered at the absolute fringes of respectability, cited mostly as a cautionary tale. Too old, too strange, too far outside the framework. Cerruti, Hueyatlaco, a few other scattered claims in Brazil and other parts of the Americas, each hinting at deep antiquity, each fiercely debated. Taken together, they form a pattern of possibilities, but not yet a solid history. It is tempting to weave them into a grand narrative. Denisovan sailors following the coastlines along the Pacific, camping on beaches that would one day become California and Chile. Neanderthal hunters following herds across a frozen Beringia, leaving footprints in snow that melted 120,000 years ago. Ghost populations, unknown branches of the human family tree reaching the Americas in waves we have barely begun to imagine. But for now, these are thought experiments, speculations. The genetic hints of ghost populations are real, but they point primarily to ancient events in Eurasia. The archaeological claims for very ancient humans in the Americas are intriguing, but they are not widely accepted. They could be the sign of something revolutionary, or they could be misinterpretations of complex geology. Science moves slowly here because it has to. We know modern humans interbred with Neanderthals, and we know those genes flowed down into the ancestors of the indigenous peoples of the Americas. We know those ancient encounters shaped how the bodies of the first Americans reacted to new climates, new diseases, new foods. We also know our family tree is messier than we ever imagined. Not a neat branching diagram, but a tangled web of crossing and recrossing, with phantom branches that only show up as faint genetic echoes. Could Denisovans have looked across a Pleistocene shoreline toward a distant American coast? Could other archaic humans have walked these continents long before Homo sapiens? Perhaps. For now, the evidence is a collection of soft whispers, not a chorus. A few anomalous sites, a handful of controversial dates, a lack of clear, repeated patterns that would turn mystery into history. So we tread carefully. The first Americans, as far as the overwhelming majority of the evidence shows, were modern humans. But they were not alone in the deeper story that led to them. They carried within them Neanderthal genes, Denisovan genes, and perhaps the faintest traces of other nameless ancestors. When they crossed into this new world, they brought all those ghosts with them. And as we follow their tracks through skulls, skeletons, and ancient graves, the mystery only deepens. This chapter of the story doesn't begin in the Ice Age, but on a hot July day in 1996. Two college students are watching a hydroplane race on the Columbia River in Kennewick, Washington. The water level is low. Erosion has eaten away the riverbank, exposing layers of mud and gravel that haven't seen sunlight for millennia. One of the students wades into the shallows and stumbles over something hard. At first, he thinks it's just a rock. Then he looks closer. It is a human skull. The police are called. The area is cordoned off. Everyone assumes it's a recent death. A drowning, perhaps, or something darker. The coroner takes a look, expecting to open a modern forensic case. But as the skull is cleaned, something becomes obvious. It isn't recent. The bone is weathered, heavily mineralized. A stone spear point is lodged in the hip, and the teeth and cranial sutures indicate this person lived thousands of years ago. Radiocarbon dating returns a number that shocks everyone involved. Roughly 9,000 years before the present. This wasn't just a skeleton. It was one of the oldest and most complete human remains ever found in North America. He would eventually be known by many names. To scientists, Kennewick Man. To the local indigenous nations, the Ancient One. An ancestor, a relative. A person who never stopped belonging to their land. And almost immediately, these bones became a battlefield, not just of law and politics, but of what it means to belong to a place, and how diverse the earliest Americans truly were. When the skull is first examined, a chain reaction begins that will define the Skull Wars. Some early observers, mostly physical anthropologists, trained on Old World skull collections, make what they think is a purely descriptive remark, but one that will have massive consequences. They say he doesn't look Native American. The shape of his face, his narrow nose, his cranial proportions. They claim these features are more similar to populations from Northeast Asia, the Ainu of Japan, or even vaguely European, rather than the modern Native Americans they are used to seeing in their reference sets. And in the 1990s, in American anthropology, that kind of comment doesn't just stay technical. It resonates with old, dangerous ideas. Ideas that will fuel fringe theories about ancient Caucasoid Americans. Ideas that some groups will seize upon to argue that the original inhabitants here weren't the ancestors of modern tribes at all. The skeleton resting quietly in a storage box has no idea that the shape of his cheekbones is about to be dragged into federal court. Legally, everything revolves around a law passed in 1990. The Native American Graves Protection and Repatriation Act, or NAGPRA. It states, essentially, that Native American human remains and sacred objects held in museums and federal collections must, when possible, be returned to their tribes. It is a response to centuries of grave robbing, museum collecting, and scientific study conducted without consent. A small partial attempt at making things right. So when the age of the Kennewick remains is confirmed, 5 local tribes, including the Umatilla Yakama Nez Perce and others, say something simple and powerful. He is ours, not as property, but as family. They ask that he be reburied according to their traditions, without further disturbance. But a group of scientists, many of them prominent in the field, sees the skeleton differently. To them, he is a once-in-a-lifetime find, a chance to understand what people looked like at the dawn of the Holocene, to study diet, injuries, disease, and migration patterns. They sue the U.S. government for the right to study the remains. They argue that under NAGPRA, you have to demonstrate some cultural affiliation with a modern tribe before you can claim remains. And they say, we can't do that here. He's too old. He doesn't look like modern Native Americans. The evidence for connection, they insist, is insufficient. The tribes respond with a different logic. We have been here since time immemorial. Our oral histories say so. Our relationship with this river, with this landscape, is unbroken. If he lived here 9,000 years ago, he is our ancestor by definition. The fact that his skull doesn't match your museum collections is not our problem. The court case drags on for years. Lawyers debate bone measurements. Anthropologists testify on cranial indices. Tribal elders speak of the responsibility to the dead. And all the while, the Ancient One sits in a storage facility, boxed up and catalogued, waiting for a decision on who, if anyone, truly has the right to speak for him. Beneath the legal arguments lies a deeper scientific assumption, one that turns out to be wrong. An assumption that you can look at a 9,000-year-old skull, compare it to modern populations, and declare that it belongs to one group and not another. That the shape of a face is fixed. That the diversity of today is what diversity has always been. But the early Holocene wasn't like that. When researchers began looking not just at Kennewick, but at other ancient American skeletons from Brazil, Mexico, Florida, and elsewhere, a pattern emerged. These early skulls are wildly diverse. Some have broad, rounded faces. Some are long and narrow. Some look like the averages of modern Native Americans. Others look more like Pacific Rim populations, or even vaguely European when viewed through the biased lens of old racial categories. Yet when DNA, if it is available, can be extracted and sequenced, a quieter, more consistent story appears. Genetically, they are all deeply Native American. They share ancestry with the modern indigenous peoples of the Americas. The bones say, we look like everything. The DNA says, we belong here. In the case of Kennewick, it takes time for the technology itself to catch up. When the lawsuits are being argued, ancient DNA work is still in its infancy. Bone preservation is delicate. contamination is a constant danger. For years, the genetic story of the Ancient One remains silent. Meanwhile, the skull measurements and facial reconstructions continue to be dragged into public debates they were never designed to settle. Some reconstructions give him a vaguely European appearance. They circulate in the media, on websites, in books, stripped of nuance, stripped of uncertainty. They fuel narratives that indigenous peoples rightly perceive as threats. Narratives suggesting their claim to this land might be secondary, that someone else was here first. But science doesn't stand still. By the early 2000s, new techniques for extracting and sequencing DNA from ancient bones become available. The same revolution that unlocked Neanderthal genomes and Denisovan finger bones is now applied to much younger skeletons, much closer to the present. In 2015, a team manages to get enough genetic material from Kennewick to run a full analysis. When the results come in, they slice through decades of speculation with an almost unsettling simplicity. The Ancient One was most closely related to modern Native Americans. Specifically, he shows a strong genetic affinity with Pacific Northwest tribes, including some of the very same tribes that had claimed him as an ancestor from the beginning. The shape of the skull had been deceiving. The DNA was not. The tribes had been right all along. He is one of ours. Genetics finally agreed. After the genetic evidence is published, the legal landscape changes. The government recognizes that under the law, cultural affiliation has been established. The arguments over cranial measurements fall apart. In 2017, more than 20 years after his discovery, the Ancient One is finally returned to the tribes. He is reburied in a private, confidential ceremony. No cameras, no scientific instruments, just prayers, songs, and the quiet closing of a circle that had been open for 9 millennia. The Skull Wars, at least in this chapter, end not with a dramatic courtroom verdict, but with a simple act of respect. A human being is allowed to rest in peace. But the scientific questions raised by these bones remain. Why did he look so different from many modern Native Americans? Why do the earliest American skulls, from north to south, present such a wide array of shapes? What does this say about how the first Americans arrived, and how they changed once they were here? There are several possibilities. The first is that the original peoples of America carried far more morphological diversity than we see in later populations. Remember that the small group that crossed from Siberia into Beringia didn't come from a uniform, homogeneous population. It was already the product of multiple ancestral streams in Northeast Asia, each with its own subtle cranial tendencies. When you push a small, varied group through the harsh filters of Ice Age survival, you can end up with lineages whose facial structures diverge rapidly in many directions at once. Another possibility involves multiple waves of migration. Not just one founding group moving south, but several waves of people entering the Americas over thousands of years. Some hugging the coast, others pushing through inland corridors, still others arriving later. These waves might have mingled, or in some cases died out without leaving direct descendants in the modern gene pool. In this scenario, some of the unusual skull shapes we see might be the echoes of populations that no longer exist as distinct genetic lineages. Lost branches of the American family tree, their genomes dissolved into others, their faces preserved only in bone. A third factor is rapid local evolution. Bone is a living tissue. It reacts to diet, climate, and activity patterns. shifting from hunting megafauna in open plains to gathering shellfish along cold, windy coastlines can over thousands of years subtly remodel jaws, nasal cavities, and cranial vaults. The same genome, expressed under different environmental and cultural pressures, can produce surprisingly distinct skulls. Add them all together: diverse founders, multiple waves, local adaptation, and pure chance, and the early Americas become a kaleidoscope of faces, all part of the same great founding population, all connected at the genetic level, but visually incredibly varied. Kennewick Man stands at the center of this picture as a kind of reminder. A reminder that you cannot read deep ancestry on a face as if it were a barcode. That categories like looks Native American, looks European, or looks Asian are modern, clumsy constructs, poorly suited to a world where populations were smaller, more fluid, more experimental. And a reminder that even when the science is fascinating, there are people for whom these bones are not data points. They are grandmothers and grandfathers. The Skull Wars revealed how easily scientific curiosity can slip into what indigenous communities feel is yet another form of appropriation. To scientists, ancient skeletons are precious because they are rare windows into the past. To indigenous nations, they are precious because they are not things. They are people who lived, loved, suffered, and died, and who still have relatives walking the earth. The Kennewick case forced anthropology to confront this tension directly. Who has the right to ask questions of the dead? How many questions are enough? When does knowledge stop justifying cutting, sampling, and disturbing? There is no easy, universal answer, but the resolution of the Kennewick story suggests a path forward, one where science continues not as an automatic right, but as a negotiation, a partnership where indigenous rights and knowledge are not obstacles to research, but part of the framework that makes the research legitimate in the first place. And in a way that reflects the history we saw with Neanderthals and the multiple human groups interacting, overlapping, sharing genes and ideas, sometimes cooperating, sometimes competing in the modern world. Multiple ways of knowing collide and overlap as well. Western science, indigenous oral history, legal structures, ethical traditions. Sometimes they clash, sometimes they find a way to coexist. Kennewick Man stood at the crossroads of these forces. A single skeleton emerging from a riverbank forced us to reconsider what ancient Americans looked like. How many different groups might have roamed these continents, and how much diversity was lost before written history began. It also forced us to ask ourselves, in the rush to answer these questions, who decides what becomes of the dead? As we push deeper into the continent's past, as we begin to sequence older genomes, as we uncover more skulls that don't fit our expectations, this intersection between science, ethics, and indigenous rights will not disappear. It will become increasingly important. The bones we study are not just clues about migration routes and population splits. They are also tests of whether, in trying to understand the first Americans, we can avoid repeating the mistakes we made with their descendants. And with that in mind, we can turn from the shape of ancient faces to the code written inside their cells. Because while skulls can deceive us, DNA can sometimes bring a different kind of clarity. The genetic revolution is about to open an entirely new window onto the peopling of the Americas. Genetics is where the story stops being conjecture and starts being testable. Not perfectly, not completely, but enough that we can see outlines where before there was only fog. For most of the 20th century, everything about the first Americans came from stone, bone, and a lot of arguing. Then, quietly, in cold rooms filled with humming machines, that changed. Ancient DNA technology is one of the strangest things humans have ever invented. Imagine taking a bone that has sat in the ground for 10,000 years, grinding a tiny piece into powder, and asking it to tell the story of its life. For a long time, it was science fiction. DNA degrades. It breaks into fragments. It gets contaminated by bacteria seeping through the soil. Early attempts yielded confusing, unreliable results. But then the methods improved. Clean rooms got cleaner. Sequencing became faster and cheaper. Algorithms learned to sort ancient human DNA from the noise of microbes and modern contamination. Suddenly, skeletons that had been silent for millennia began to speak. And what they said about the first Americans looked nothing like the neat, tidy pictures so many people were used to. You can think of DNA as a clock running in slow motion. With every generation, tiny random changes accumulate. Compare two populations, and the pattern of those changes tells you roughly how long ago their ancestors split apart. Not the exact village, not the precise number of people, but the order of events, the branching of the tree. When geneticists began comparing Native American DNA to populations around the world, one thing became immediately clear. Their closest relatives were not in Europe. They were not in Africa. They were in Northeast Asia. In Siberia, the Russian Far East, and parts of northern China. Time and time again, the signal returned exactly the same. Native Americans are deeply, consistently linked to ancient and modern East Asians. But the details were stranger. Based on these genetic clocks, the founding population that would eventually give rise to all the indigenous peoples of the Americas seems to have split from other related East Asian groups roughly 25,000 to 30,000 years ago. Not 12,000, not 15,000, but tens of thousands of years before the Clovis culture appeared in North America. Long before those footprints at white sands were pressed into the wet mud of the lake. That meant something important. If the ancestors of Native Americans separated from their Asian cousins 25 to 30,000 years ago, but the oldest widely accepted archaeological sites in the Americas are much younger than that, then those ancestors must have been somewhere for a very long time. That somewhere forms the basis of one of the most interesting ideas in this entire story: the Beringian standstill. During the peak of the last ice age, sea levels were lower, exposing a vast landmass between Siberia and Alaska. Not a little bridge you could jog across in an afternoon, but a region the size of a small continent. Grassy steppes, forested zones, herds of mammoth and bison. Beringia. The Beringian standstill hypothesis proposes that the ancestors of Native Americans didn't just sprint across this land and vanish into the continent's interior. Instead, they lingered for thousands of years, isolated, trapped, in a sense, between walls of ice to the east and south and harsh environments to the west. A population caught in a frozen waiting room. Their DNA seems to carry this history. Native American lineages form their own distinct branch, separate from other East Asian groups. But they also show signs of having been a small, relatively isolated population for a long period. The genetic echo of a people living across a vast region, growing slowly, adapting to a cold, wind-swept world as the ice sheets reached their maximum and then began to retreat. When the climate shifted, and the glacial margins pulled back, these Beringian descendants finally had new options. Some followed the coast, moving along the kelp forests and rich marine ecosystems. Others slipped through ice-free corridors inland. However they arrived, they brought with them a genetic signature that still defines the vast majority of indigenous peoples from Alaska to Patagonia. But the DNA doesn't just speak of a single wave. It whispers of eddies, backflows, and side channels. As geneticists looked closer, they began to notice patterns that didn't fit a simple one migration, one population model. Certain Native American groups in North America show evidence of slightly different ancestral components than some groups in South America. Ancient skeletons from different periods don't always match the same neat profile. There were hints of additional waves of people entering the Americas later on, merging with those already there, and even hints of people moving in the opposite direction, back toward Asia. These back migrations are subtle, but they are there. Some modern Siberian populations carry genetic traces that look distinctly Native American, suggesting that not everyone who headed east stayed there. Some groups may have trickled back to the Asian side of Beringia over thousands of years, carrying American-born lineages with them. Inside the Americas, the story is equally layered. Genetic studies point to at least two main branches splitting from the original founding population. One that gave rise to most indigenous peoples in Central and South America, and another that seems more restricted to parts of northern North America. Over time, migrations, separations, and reunions created a tapestry of related but distinct groups, each with its own history, its own pathways, its own adaptations. One of the most important pieces of this puzzle doesn't come from a theory, but from a heartbreaking grave in present-day Montana. In 1968, on a small ranch near the town of Wilsall, workers uncovered the burial of a toddler. The child had died roughly 12,600 years ago, near the end of the Ice Age. He was buried with great care, surrounded by finely crafted stone tools and red ochre. Archaeologists came to call him the Anzac child, after the family who owned the land. For decades, these bones rested in collections, silently bridging a gap between Clovis-era artifacts and living peoples. Then in the 2000s, with the permission and cooperation of tribal representatives, scientists extracted DNA from his remains. What they found was astounding. Genetically, the Anzac child was clearly Native American. Not a lost European, not a mysterious alien species, but a direct representative of that same great lineage that still exists across the Americas today. His DNA showed close relationships with indigenous peoples of Central and South America, as well as North America. That meant that 12,600 years ago, the descendants of that original Beringian population had already spread far and wide across the continent and were part of the very same family tree as living Native Americans. In other words, the people making Clovis points in Montana weren't a dead-end culture. They were ancestors. The Anzac genome also undercut some of the more speculative ideas about entirely separate ancient populations being wiped out and replaced by later arrivals. It didn't disprove all possibilities of earlier waves, but it showed clear continuity. The faces of the past and the faces of the present are connected by unbroken genetic threads. But not all the threads are so simple. When researchers examined the genes of certain indigenous groups in the Amazon rainforest, they noticed something very strange. A tiny sliver of their ancestry seemed to resemble modern populations from Australasia, people from places like Papua New Guinea and parts of Australia more than it resembled other Native American groups. This didn't mean Australians had somehow sailed directly to Brazil 13,000 years ago. The signal is subtle, and it doesn't match any known modern population exactly. Instead, it suggests that an ancient group distantly related to the ancestors of today's Australasians contributed genes to the ancestors of certain Amazonian peoples, and then vanished as a distinct population. Geneticists sometimes call this hypothetical group Population Y, from the Tupi word Ipiquera, meaning ancestor. We don't know where they lived. We don't know what languages they spoke or what their tools looked like. They might have split off from other Asian populations before the main founding group that became Native Americans. They might have met and mingled with those founding populations in Siberia, in Beringia, or even very early on within the Americas. And when that happened, their trace remained, a faint Australasian-like echo in the genomes of some Amazonian communities, speaking of encounters and journeys that left no known bones, no clearly labeled archaeological sites. Just a ghostly genetic footprint. This is the paradox of DNA. It can be exquisitely precise, down to the single mutation, and at the same time profoundly mysterious. It can tell you that two people share an ancestor, but not what that ancestor believed or the stories they told around the fire. As more ancient genomes are sequenced from Alaska, Mexico, Brazil, Patagonia, the picture becomes richer but not simpler. Some early individuals in North America show ancestry that branches off near the very base of the Native American tree, suggesting diversity very early in the peopling process. Others, thousands of years later, carry mixtures of once separated lineages, proving that human groups were meeting, trading, intermarrying, and reshaping their mutual futures. Through it all, one conclusion has become very hard to deny. Native Americans, in all their incredible diversity, ultimately descend primarily from populations in Northeast Asia. The old arguments attempting to place their deepest origins in Europe or elsewhere have steadily eroded under the weight of genetic evidence. The DNA points in a general direction, back across the Pacific, toward Siberia, toward East Asia, toward Beringia. But that doesn't mean the story is simple, or that it can be summarized by, "They just walked across the bridge once, and that was that." Instead, genetics has revealed a history of prolonged isolation and sudden expansion, of multiple waves and quiet returns, of lost branches and ghost populations that left no obvious trace except inside the cells of the living. It is also important to remember something else. Genes are not destiny. They do not tell you who owns a history or how that history should be told. They are one line of evidence among many. Archaeology, linguistics, oral traditions, and lived experience all carry truths that DNA alone cannot capture. Yet the genetic revelations of the past few decades have accomplished something profound. They have linked ancient children, like the one buried at Anzac, to modern communities in a direct, tangible way. They have shown that the first Americans were not some mysterious, unrelated species that vanished without a trace, but the direct ancestors of indigenous peoples whose cultures, languages, and histories continue today. And they have reminded us that the peopling of the Americas was not a single event. It was a process spanning tens of thousands of years, shaped by ice and ocean, by chance and adaptation, by separation and reunion. As you drift toward sleep, You might picture these genetic lineages not as lines on a chart, but as rivers. A main channel flowing from Asia into the New World. Tributaries splitting off and merging. Hidden springs fed by ghost populations we only know from faint signals. Back eddies swirling outward, returning centuries later. Every person living in the Americas today carries in their cells the record of this long, winding journey. A journey that began in the deep cold of the North, paused for millennia on a drowned land between continents, and then unfurled across forests, mountains, prairies, and coastlines. A journey that, thanks to ancient DNA, we are finally beginning to see, even if only in brief glimpses. But genes can only tell us who was here and how they were related. To understand what the lives of these first Americans actually looked like, the sounds, the dangers, the animals that walked beside them, we have to turn to an entirely different kind of evidence. Imagine this. You open your eyes on a freezing morning, not in Africa, not in Eurasia, but in a world that no longer exists. A continent still half frozen from the last glacial maximum. The air is crisp, sharper than anything you have ever felt. Your breath comes out in white clouds, instantly vanishing into the pre-dawn dark. Above you, the sky is so clear, you can see stars all the way down to the horizon, as if someone had spilled crushed ice across black velvet. And stretching out in every direction as far as you can see is a world that might as well be alien. This is Pleistocene America, not the land of highways, skyscrapers, and cornfields. A lost world of giants. Out on the open steppe, herds of mammoths move like slow, living hills. Shaggy silhouettes against the snow, each one twice as large as anything you have ever hunted. Some are woolly mammoths with thick hair and curved tusks that sweep almost all the way back to their shoulders. Others, further south, are Columbian mammoths, taller, leaner, adapted to slightly warmer grasslands. In the timberline beyond, mastodons browse among the conifers. They look like mammoths at first glance, but up close they are different. Shorter, stockier, with straighter tusks and different teeth, built not for grazing open plains, but for stripping branches and crushing leaves. If mammoths are the bison of this world, mastodons are the forest elephants. Up on the ridges, shadows move that are not human. A massive shape crests a hill and pauses, watching the mammoths with eyes that catch the faint light. American lions, larger than any African lion today, moving without fear. Packs of dire wolves trail the herds, heavier and more powerfully built than modern wolves, their jaws made to crush bone. Saber-toothed cats crouch near the watering holes, their front fangs so long they look almost impossible, like something dreamed up in a fever. And lumbering through the brush, tearing down low vegetation with immense clawed forelimbs, are creatures you have no name for. Giant ground sloths, some as big as elephants, slow but not defenseless. A single swipe of those claws could open a human from shoulder to hip. Beavers the size of black bears build lodges along the rivers. Armadillos as big as small cars. Glyptodonts roll across the plains inside bony shells like living tanks. This is the America the first humans saw. Not a pristine wilderness waiting for us, but a crowded, dangerous, impossibly rich ecosystem that had been shaping itself for millions of years, with zero expectation that one more primate, armed with firestone and plans, was about to arrive. When your ancestors first set foot here, whether down the coastal routes along the Pacific kelp forests through an ice-free corridor that opened between massive continental glaciers, or by some path we haven't found yet. They didn't just discover a new land. They walked into someone else's world. And just like every other world our species walked into, the first question was simple. Can we survive here? The evidence suggests the answer was yes, and quickly. Archaeological sites scattered across North and South America show signs of human interaction with megafauna almost as soon as humans appear in the record. This isn't just an occasionally scavenged carcass, but structured, repeated behavior. In a place like Dent, Colorado, mammoth bones lie in unusual arrangements, some clearly broken while still fresh, rich in marrow, likely butchered by humans. At Murray Springs, Arizona, mammoth remains are found alongside beautifully crafted stone spear points, burned areas, and processing debris. Out on the Great Plains, sites like Lang Ferguson show mammoth bones split with tools bearing cut marks in patterns no carnivore's tooth would make. Far to the south, in places like Arroyo Seco in Argentina, there are layers of bones from giant ground sloths, horses, and mastodons, showing cut marks, impact fractures, and evidence of controlled fire. You can almost reconstruct the scenes. A small band of hunters wrapped in furs, tracking a wounded mammoth for miles across windswept prairies. The animal bleeding, slowing, stumbling. Carefully napped stone spear points lodged deep in its muscles. The final encounter at a frozen stream. Shouts, coordinated movements, another volley of spears. Then silence as the giant collapses. Finally, for your people, a kill like this isn't just a meal. It is survival for weeks. Meat to dry and smoke. Bones for tools, hides for clothing tents, snowshoes. Sinew for bindings and bowstrings, fat for lamps. A single mammoth can sustain a small band through the kind of winter that would kill you in days without adequate calories. Was it hunting, or was it opportunistic scavenging? The truth is, it was probably both. Sometimes animals died in bogs or river crossings, and humans moved in afterward. Sometimes predators brought them down first, and clever scavengers with stone blades stole their share. But over time, the evidence becomes harder to explain as mere opportunism. We find kill sites containing multiple animals in one place. Bone beds, where mammoths or bison seem to have been driven into marshes or over small drop-offs, suggesting planned communal hunts. We find carefully crafted spear points lodged in vertebrae, pelvises, and ribs, in a way that implies the deliberate targeting of vital areas. And here is where things get even more interesting. There are hints, just hints, that humans weren't always solely the enemies of the megafauna. In certain caves and rock shelters, some bones appear to be arranged deliberately, not just discarded. Mammoth and mastodon bones used to build windbreaks or shelters, the repeated association of certain animals with possible ritual spaces. A few researchers have even speculated about early attempts at something akin to management or proto-domestication, not in the sense of neatly fenced herds, but habitual patterns of following certain groups of animals, learning their migrations, perhaps repeatedly guiding them toward favorable terrain. A kind of low-level landscape engineering long before the formal appearance of animal husbandry elsewhere in the world. We don't know how far it went. The evidence is fragmentary, scattered across thousands of miles and tens of thousands of years. But it suggests a relationship between humans and megafauna that was complex, dynamic, and constantly evolving. And then, abruptly, in geological terms, the giants vanished. Between roughly 13,000 and 10,000 years ago, a massive proportion of American megafauna disappears from the fossil record. Mammoths, mastodons, giant ground sloths, saber-toothed cats, American lions, dire wolves, glyptodonts, giant beavers, American camels, native horses. Species that had survived multiple previous ice ages simply faded away. Why? It is one of the great unresolved debates in science. On one side, there is climate. The end of the last ice age was a time of rapid, dramatic change. Glaciers retreated. Sea levels rose. Vegetation zones shifted hundreds of miles in a matter of a few thousand years. Animals that had evolved for the cold, open steppe suddenly found themselves in warming forests or shrinking grasslands. Many couldn't adapt fast enough. On the other side, there is us. The overkill hypothesis suggests that even relatively small human populations, armed with cooperative hunting strategies and increasingly sophisticated tools, could have exerted enormous pressure on slow-breeding megafauna. Just a few extra deaths each generation can push a population past its tipping point. And like most important questions in human evolution, the true answer might not be one or the other. It might be both. Climate stress, pushing ecosystems to the brink. Human hunting, pushing vulnerable populations over the edge. Add in possible diseases, habitat fragmentation, and competition with other species, and you get the picture of a world unraveling. But for the people who lived through it, this wasn't an abstract extinction event. It was daily life. Imagine being born into a world where mammoths are common, their tracks carved into the earth like ancient highways. The stories of your childhood are full of them. The traditions of making your tools are built around their bones and hides. Your social rituals revolve around the first successful mammoth hunt, the sharing of the meat, the songs sung afterward. Then, over a few generations, they become scarce. Then they disappear. You would have to reinvent almost everything. The daily life of these first Americans was not a single uniform experience. It depended entirely on where you lived. In the far north, near the retreating ice sheets, people followed caribou and muskox, and later, after the giants were gone, small game and fish. They learned to build shelters, partially sunken into the earth, lined with bone and hide, insulated against killing winds. They refined clothing technology into an art form. Layered furs meticulously stitched with bone needles, so no heat could escape. Along the Pacific coast, groups harvested shellfish, salmon, and marine mammals, moving to the rhythm of the seasons between rich estuaries and sheltered coves. They built boats, perhaps simple dugouts at first, then more sophisticated watercraft, navigating the kelp forests and rocky shores. The cadence of their world was set by the tides, the spawning runs, the migrations of seals and seabirds. In the inland plains, people followed the herds across vast open spaces. Not just mammoths and mastodons, but later bison and pronghorn antelope. They learned to read the wind, the faintest tracks in the dust or snow, the subtle shifts in the sky that signaled a blizzard. Some camps were temporary, just a few days at a kill site. Others became seasonal hubs, visited time and again, leaving behind thick layers of stone flakes, charcoal, and bone. Further south, in what would one day become deserts, lay wetlands and grasslands rich with game. Down into the tropical regions of Central and South America, humans pushed into dense forests full of unknown species: jaguars, tapirs, capybaras, monkeys. They had to invent new strategies, new tools, new ways of thinking, almost from scratch. One continent, dozens of worlds. Over time, regional cultures blossomed. You can see it in the stone tools. Different shapes, different techniques, different choices of raw material. Some groups perfected long, elegant spear points, razor sharp, and fluted at the base, so they could be hafted securely. Others focused on scrapers and knives optimized for working hides or processing plants. You can see it in the layout of the camps. Some emphasize big game hunting. Others show a heavier reliance on fish, shellfish, or small animals. Some hold evidence of long-distance trade, exotic stones and shells transported hundreds of miles inland. Pigments brought from distant sources. Exchange networks quietly linking bands that might never meet face to face, but who relied on each other all the same. These were not people passively enduring a difficult world. They were actively probing it, experimenting, learning which plants could be eaten raw, which required processing, which cured headaches, which stopped bleeding. Testing rivers and lakes for fish runs, mapping the seasonal shifts in animal behavior. Every mistake had a price. The wrong plant could kill you. Misjudging the ice on a river could sweep away a child. Underestimating a cornered ground sloth or a bison could mean shredded muscle and shattered bone. But the survivors didn't just accumulate scars. They accumulated knowledge. By the time the mammoths vanished from the earth, the first Americans had already diversified into a tapestry of cultures and ways of life adapted to almost every environment the continent could offer. Tundra forest, prairie, coast, mountain, and jungle. The ingenuity that had carried their ancestors through the African bottleneck was still at work here on the other side of the world. New tools, new hunting strategies, new social arrangements, likely new languages, new myths, new ways of explaining why the world was changing, and why the giants from their grandparents' stories no longer walked the earth. If you could stand with them on the shore of a meltwater lake, watching the last thin sheet of ice crack beneath the warming sun, you might feel something unexpected. Not just fear, not just struggle, but wonder. Because as harsh as it was a world overflowing with life. Herds stretching to the horizon, predator tracks crisscrossing in the snow, the smell of mammoth dung carried on the wind, the sound of thousands of birds taking flight from a marsh all at once, turning the sky into a living cloud. The first Americans didn't walk into an empty space on a modern map. They walked into a lost America that no human will ever see again. A continent of monsters and marvels. And somehow, amidst all that danger and beauty, small bands of our close relatives figured out how to live, how to track giants in the snow, how to cross frozen rivers in the dark, how to sing children to sleep to the sound of distant thunder and the deep, strange calls of animals that today exist only as bones in a museum. When we dig up those bones and trace the cut marks on their surface, when we follow the patterns of ancient hearths and stone flakes, we aren't just reconstructing ecology. We are remembering the meeting between a species forged in one of the worst climate catastrophes on Earth and a land that had never seen anything like us. What happened in that meeting? The hunts, the extinctions, the innovations, the quiet acts of daily survival set the stage for everything that would follow. The rise of complex societies in the Americas, the histories carved into rock and woven into oral traditions, the genetic signatures still carried by the people of these continents today, and the mystery thickens still. Because the more we learn about this lost world of mammoths and megafauna, the more we realize something unsettling. We still do not fully understand who these first Americans were, or how many different kinds of humans walked beside them, leaving only faint genetic echoes and fragments of bone in the shadows of a vanished ice age. So now here we are, at the end of this journey, looking back across tens of thousands of years. And the story we began with looks nothing like the story we end with. There was a time when the peopling of the Americas seemed simple. Clovis First. One migration, one land bridge, case closed. You could draw it as a single arrow on a map and feel like you understood it. Now that arrow has shattered into a web. Instead of a clear migration, we see wave after wave, people slipping down an ice-free corridor, others gliding along a coastal Kelp Highway in boats we have never found. Possible Atlantic crossings fiercely debated in academic halls. Denisovan echoes in the genomes of modern populations. Ghost lineages we can see in the DNA, but not yet in the bones. Skulls that do not fit neatly into the categories we invented for them. What was once a straight line has become a braided river, splitting into channels, looping and recombining, disappearing underground, only to surface thousands of miles away. And the truth is, we are still only seeing fragments. We do not yet know who left the very first footprints on those ancient American shores. We do not know how many times humans came, or how many distinct cultures rose and fell long before the Clovis hunters fluted their famous points. We do not know how many languages vanished, how many mythologies were never written down, how many names are lost to time. When we talk about the first Americans, we are really talking about layers of mystery. Footprints in evaporated lakes, stone tools beneath old assumptions, strands of DNA whispering that someone was here, but we do not yet know their face. But even with all these gaps, one thing shines through clearly. Whoever they were incredibly adaptable. They followed retreating glaciers. They tracked herds across frozen plains and dense forests. They fished in rich kelp forests along stormy coasts. They learned new plants, new climates, new dangers. They crossed mountain ranges, deserts, and river systems the size of small seas. And they didn't just survive. They built histories, rituals, technologies, worlds. To understand their migration is really to understand ourselves. The same brain that calculated the tides for a coastal crossing is the brain that built cities. The same creativity that turned mammoth bones into shelter is the creativity that paints art on cave walls or digital screens. The same stubbornness that pushed families across the Bering Land Bridge, through the ice-free corridor, or down the Pacific coast, is the stubbornness that carries us through our own private winters. And through it all, there is a deeper truth that matters more than any single theory about dates or roots. The descendants of these first peoples are still here, for thousands of generations. Indigenous nations across the Americas have held on to the land, the language, and the ceremonies. They carry living memories, oral histories, sacred stories, and knowledge tied to places that stretch back in time in ways archaeology is only just beginning to appreciate. When we talk about the first Americans, we are not talking about vanished strangers. We are talking about the ancestors of real communities living today, with their own perspectives on this history. As we follow the science, it is important to remember that these are not just puzzles to be solved. They are human stories to be respected. As you settle into sleep, perhaps let your mind drift with these ancient travelers. Imagine a small group standing on a wind-swept shore, watching the waves break against a coast no human has ever seen before. Imagine children running beside mammoths in an Ice Age meadow. Imagine canoes gliding through kelp forests beneath a sky filled with unfamiliar stars. Somewhere in that long chain of journeys, someone took a step that eventually led all the way down to you. If you enjoyed wandering into this mystery tonight, you can gently tap the like button or subscribe to the channel so you don't miss the next late-night expedition into deep time. If you feel like sharing, you can leave a comment telling us where in the world you are listening from, adding your own point to this vast map of human movement. And if you'd like to support the channel a little more, an optional YouTube membership is available. It is never required, but always appreciated, and it helps us keep making these quiet, curious dives into the past. For now, you don't need to solve anything. The unanswered questions will still be there tomorrow. Let the timelines blur. Let the maps fade. Let the glaciers and the coastlines dissolve into the dark. You can close your eyes and imagine the crunch of ancient snow, the whisper of a pine forest, the soft press of bare feet in the wet sand 20,000 years ago. Thank you for spending this time here at the edge of what we know. Sleep peacefully. May your dreams be filled with long journeys, distant horizons, and the quiet footsteps of ancestors walking beside you in the dark.